Like a nightclub action. Okay, this is just a short little presentation I put together, just continuing my series of some astronomical misconceptions. So I've gone through that Sadler thesis, and I finished all of the misconceptions he came up with, so I just kind of went through and came up just with 3 tonight to go through quickly. Okay, so the first one is based on we got it from a book that I bought by Greg Quick called Earth Turning Consciousness. He's an amateur astronomer that lives in Broome, Australia, and he wrote this little book about some of the observations that he does. He teaches courses about astronomy, and one of the things he likes to talk about is about how the Earth moves around the sun and the various movements. And one thing he talks about is the rising and setting of the sun. He says that's flat Earth talk. The sun doesn't rise and set. And some of the, there is Great Quick there. One of the things he says is that we live on a planet that's turning as it hurtles through space and moving in a number of different directions at the same time. And these movements are happening to us whether we realize it or not. And he's really, really eloquent about it. His book is really wonderful. And he also has some YouTube videos online as well, which are quite entertaining. So, basically, he says to people that there's really only two things to remember, is that the Earth is round, and that the Earth spins on its axis once a day. Now this is all really basic. This is really 101 here. Well, one thing I thought was interesting as I thought about it is that for those of you who have telescopes that can track objects, when I thought about it, it's like those telescopes really aren't tracking anything at all. They're actually not moving.
They're moving the mountain.
And what's moving is the Earth is moving, and we're moving with it. So those telescopes are just pointed at the same direction in space. I thought that was kind of cool. So anyway, that was a really wonderful book. I do have it at home. I'll sure bring it in sometime to show people, because it's pretty good. And I like his philosophy too. He seems like a pretty cool guy, I guess, living along the shoreline in northwestern Australia. Just is pretty cool.
Northwestern?
Okay, and as Carol mentioned earlier, with solstice is coming up in December, and we just had equinox last month. So I thought it's always kind of a cool thing to talk about the reason for the seasons. And so I kind of looked at this topic a little bit. I'm sure a lot of you are familiar with this diagram here, showing basically, I have this model here showing the orbit of the Earth around the sun. So the sun oriented this way on December 21st. The light comes in like this, and it lands right on the Tropic of Capricorn. And then conversely, in the summertime, we're on the other side of the sun relative to where we are in the wintertime. And the sun is directly overhead at the Tropic of Cancer on the first day of summer. So I kind of thought what this meant with regard to the solar constant. So I had to go back to my Geography 101 notes. And so the solar constant is 1,388 watts per square meter. So what that means is any area on the Earth's surface that is directly underneath the sun receives 1,388 watts per square meter. So that's how much energy is available. But that changes as the sun gets closer to the horizon, And that can happen if your latitude changes or the time of day changes. So this is just a little diagram here to show why we have why we have more heat in the summertime. The angle of the sun in Kitchener-Waterloo, Guelph is pretty high. It's about 70 degrees above the horizon, not quite overhead. And the solar constant, it's right overhead, it's 1,388 watts per square meter. But since it's not quite overhead, it's on a bit of an angle, so that the distance that is illuminated is actually a little bit more than a square meter. It's about 1.06 square meters. So we have to divide that. So the solar flux is a bit smaller in Guelph on the first day of summer. It's about 1,304 watts per square meter. So in the wintertime, it's a lot less. So without going through all the math again, the angle of the sun is a lot lower. The sun only gets about 23 degrees above the horizon maximum on the winter solstice. And so you can see that light is spread out over a much larger area. So all of that 1,388 watts is spread out over a much, like here it's over 2.5 square meters. So on a per meter basis, it's only about 542 watts per square meter. So, and that's at noon. And then of course, as the sun rises and as it sets, that number drops throughout the day. So a lot less energy reaching us in the wintertime. So that's why it's so much colder. And then finally, the last thing here, I thought this was kind of interesting here. There seems to be this thought that, especially in movies, you ever go to a movie, they fly through an asteroid belt. They're like, there's so many of them. So, but in reality, there are not a lot of asteroids out there. They're quite widely spaced. Now, I realized when I put this on here, nobody would want to read this huge thing. And I started reading about something called the Taurid complex. And basically what that is it's a swarm of asteroids that were created by a comet that was breaking up. I've summarized that abstract over here. There was a large impact by one of the objects in the Taurid complex about 13,000 years ago, and it had some profound effects on the Earth, as you can imagine. And there's more debris in that asteroid field as well. And the largest remnant of this complex is a comet that you may have heard of called Comet NK, which I observed the first time in 2017. And was quite excited when I saw it, because I didn't think I would be able to see it, but there it was. And so Comet NK is a really short-period comet. I have it here. It has a period of about just over 3 years, and it's about 5 kilometers in diameter. Has anybody here seen Comet NK when it came around? No one's seen it? It was quite a bit brighter. I saw it with my 85 millimeter refractor, and it showed up very nicely. And dark skies were a big help too. So anyway, this comet is part of this complex, and you can see there are a lot of other objects in that complex. And even looking at it here, it looks like there's quite a few, but there really isn't that many. And it looks like they intersect, the orbit of the Earth. So this got somebody in the UK quite upset. A fellow by the name of Graham Hancock. He's a writer in the UK that specializes in pseudoscientific theories, and he said that there's an even bigger object in this complex that's like going to cause havoc on Earth. But he says it's hiding in the tail of the comet, and I'm thinking, well, if it's bigger than the comet, how could it be not visible? It just doesn't make sense. So anyway, his musings have caused a lot of unnecessary confusion. So anyway, I think, and the reason why NK or any of the objects that are associated with this complex, the reason why they're not a problem is because they orbit the sun on an angle that's steeply inclined to the Earth's orbit. So the plane of the Earth orbit. So you can see here, here's this, like this blue line here represents the orbit of the Earth. It's kind of tilted on an angle. So, and the orbit of the objects in the toroid complex, including NK, are inclined quite a ways above the orbit of the Earth. So you can see here, comet NK is actually right on the plane of the Earth's orbit when it's between Mercury and Venus, and as it moves towards the orbit, it either is above or below. Does that make sense?
Mm-hmm. Yeah.
So anyway, because space is three-dimensional. Basically, that's what I'm saying. And thank goodness it is, otherwise we'd be in trouble. So, and what can happen though is that the solar radiation can actually act upon these particles and move them in their orbit. So that can definitely happen. So it is possible that some of these objects will hit the Earth, but it'll only be the really, really small ones that the sun is able to push with the solar wind will be able to push out of their orbit. The large ones, there's no way that they will.
Trevor?
Be a problem. So.
Sure. So this is, it's in the process of making is there currently an asteroid shower, or sorry, a meteor shower named after this?
I don't know. Like I just learned about this, the toroid complex, and I don't know if it's named after Taurus or if, where that name comes from.
But one of the things that on an earlier slide, the 12,900 years ago, what was that?
Yeah, that's a good question.
Is that the driest period? There was after the Ice Age, like about the warming started about 16,000. Yes. Yeah. The warming started about what, 16,000 years ago or something?
Yeah,
like
no, that was right at the end. Yeah, that was when.
And then there was a cooler period, and I think they call it the driest, the something driest. But then there was a whole bunch of talk about, why did the megafauna go extinct? And there's a big argument, humans killed them all off, or the big megafauna couldn't stand, they couldn't stand moving. So I was just wondering if that object hitting had something to do with that megafauna destruction.
Why that maybe triggered a cooling period.
It was a younger dryas.
It's a younger.
The younger dryas, yeah. There was the Sangamonian, which was like a warming period, and then it cooled off. There was like a re-advance of the glaciers, yeah.
One of the things that I think probably related is this. What gave me made me wonder is that they have discovered two previously unsuspected asteroid or comet impacts, whatever it was, in Greenland.
Oh, okay,
In
yeah.
the ice. Yeah. And this was shown up, I guess, by what do they call that? Aperture, synthetic aperture radar or something.
Okay.
They're able to uncover the features under the ice in the rock, and it's pretty obvious there's two pretty serious size impacts there, and they've been dated to that time period.
Oh, wow.
Okay.
Okay.
And there's a suspected one in northern Ontario now, and there's another impact site they're suspecting in, I guess, western Ontario, which it doesn't look like a normal impact because it would have been ice hit first and then damage to the. So they're odd. Yeah. So and then now they're saying there's like one in South Africa, and so it could have been I don't know. It could have been more.
Okay. Yeah.
Remember, the observers list tests comets of 2020, 2P, NK, 25 June 84, and it's listed as showing up next year.
Next year. That's about right. I think I saw it in February of 2017. So yeah, that sounds about right. So it's a neat little comet. It showed up really nice in a 3-inch refractor. So
the period is either sidereal. Is that what we're looking for? The number of times it comes through, or how often it comes through, or was the ARG period.
Oh, that 3.3 years?
3.3 years is Siberia.
Yeah.
186 years is the other one.
Okay.
Anyway, it's in the book.
There you go.
Senator,
Yeah.
answer Steve's question.
Yep.
This comet is responsible for the meteor shower now.
Yeah, sorry.
The torrents.
Yeah, so that comet Encke is associated with that meteor stream. Yeah. It's one of the largest objects in it, so.
It's fresh, that's why we get fireballs. It's, the chunks are still big coming up.
Yeah. So, there we go. So we have a chance to see Encke in this next summer. And I think that's it.
I have a question about the Saturn asteroid belt.
The asteroid belt?
The Saturn belt, yeah. They are asteroids, yeah.
Well, yeah, the asteroids in
So if a spacecraft goes through that, it's not like in the movie. You
No,
have,
yeah.
No?
No, there's really not, when they add it all up, there's really not a lot of material there. But when you look at a graphic in a book, they show like lots and lots of stuff there. And in Star Wars, yeah, you're dodging asteroids because there's so many of them that. And I used to think that too. I think they worried when they were sending, the Voyager probes and the Pioneer, all these probes to Jupiter. They weren't sure, like, what was going to happen to them, but they all made it through fine.
so the belt doesn't have like small like stones or something, yeah? Or how big are these asteroids? I mean,
Yeah.
it could be like very small stone.
Yeah, a lot of them could be. Yeah, you're right.
So if a spacecraft goes through that, it could be hit, yeah?
Yeah. I think the really small ones are problematic too, because even though they're small, they're moving pretty fast.
All right, thank you very much.